All right, quiz questions. These are actually not too bad. Java's garbage collector, what does it do? Does it manage communication between CPU and memory? Search for inaccessible objects and convert their space to free space? Prevent Java programs from connecting to unsafe websites? Okay, C is just pretty silly. It is B. Searches for inaccessible objects and converts their space to free space. So you do this, you have some kind of main going on here, and you do, scanner sc is equal to new scanner system. I'm not going to bother correcting typos. System.in. By the time you're done with main, this variable disappears. The object is still there momentarily, and it's just floating out in outer space. It doesn't have any references to it, but we still have a scanner object out declared in memory. I adjusted the screen incorrectly, but nothing is pointing to it. So that's called an orphan object. There's no references to it, and that's what the garbage cleaner goes in and cleans up. So any time in local code that you have the creation of an object and then the release of it, then it's fodder for the garbage collector. So if you do something like this, say you're in main and you have this, while true, whatever, and you do animal A is equal to new animal, and then you let this run really fast. Now that's not a good example. Let's just do an if. While true, and then if something, whatever the something is, then animal A is equal to new animal. Well, the scope of that variable here, right here, is local to this block. So as soon as it leaves the if, there's nothing pointing to this object anymore. The A variable disappears, and so the animal that was created is an orphan object. If you don't want it to be orphaned, if you still want it to be hanging out, then you need to declare it somewhere else. You could declare it here, animal A, like that, and then when you come down here and do that to it, it creates it, but it doesn't disappear at the closing brace because variable A still exists, so it's not orphaned. If you finally hit a break or something that causes the while loop to exit, then by the time you get here, A disappears, and the animal object is orphaned, and the garbage collector will come and pick it up. Another thing you can do that can cause something to get orphaned really quick is if you did this. A is equal to animal, and then later on, after some code, you do this. A is equal to a new animal. You make a different one. Now you've stored something new into A. So the thing that the reference to the original object, there's nothing referring to it now. Just like if you have x equals 1 and then you say x equals 2, nothing's pointing to that 1 anymore. Well, here, nothing is pointing to our first animal, if we gave them names, Fred and then Barney. Nobody is pointing, there are no references to Fred anymore. So it's fodder for the garbage collector. It kind of hangs out until the garbage collector cleans it up, which is not instantaneous. And so if you have a loop that's repeating tens of thousands of times, you might think about ways of not creating objects inside that loop, because then you're kind of overtaxing the garbage collector. You're creating thousands of new objects a second, and you're creating, and then they're becoming orphans, and the garbage collector is supposed to clean them up. The last way is if you do this. Well, I won't say the last way. If you just set this equal to null. Null means, okay, I'm not referring to anything anymore. It's a reference variable, but it's not referring to anything. But it was referring to an object. It's not now. So again, our Fred object is now an orphan and will get cleaned up. If you do this, you set B equal to A. Now you have two references to the Fred object. So when you set A to null, it's okay because B is still pointing to the Fred object. You put two street signs up pointing to your home street. One of them gets blown down by a tornado. You still have another street sign pointing. It's okay. It's only when the other street sign is knocked down at all, as well, that you can't find your street. Nothing is referencing it. Oops. Always do that. Here we go. Overloaded methods are what? Which of these look good? To have more parameters than the maximum number of parameters allowed? Do they share memory space with tendril instance man? Okay. I ixnay this one just right from that. There's no such thing as a tendril instance variable. How about have the same name and different parameters? What do we think? A or C? Not sure I heard. It's actually C. Overloaded sounds bad, but it's not. So overloading is when you have the same name and different parameters. A constructor, we'll go back and do that one again then, is automatically called when? A Boolean variable is used. B, the object is instantiated with new. Or C, a method calls another method. B, yeah. The constructor is called by the new keyword to create a new object. Scanner equals new scanner. It hits that new keyword. It calls the scanner class's constructor. So overloading is when you do something like this. You have the same method name, but several different data types. We create something called multiply that takes two variables. And it multiplies them together, and I don't know why I made that A1, D1 and D2. And all it does is return D1 times D2. So down here inside of main, you could do, double D is equal to multiply 3 and 4. And after it was done, D would equal 12. And then you think, well, it'd be really neat if it could also multiply 3 numbers. And if it could also multiply 4 numbers. We have to write 2 more versions of the multiply method. Double mult, this one's going to take 3 parameters, double D1, double D2, double D3. And it's going to return D1 times D2 times D3. This method is an overload of the first mult method. Overloading just means that it has different parameters. Now we're going to write one that takes 4. Alrighty, same idea. Double, whoops. Did I just erase everything? No, almost. Double, multiply, double D1, double D2, double D3, double D4, and what's it going to return? D1 times D2 times D3 times D4. And this one is also an overload of the other 2 functions. So you can write overloaded methods that have different numbers of data types, or they have different data types. You might write a function that looks like this. Double display for whatever purposes, and it takes an int, and it'll print out the int, however it's going to do so. Then you might write another one that takes a string. Double display string s, and it would do whatever was necessary to display the string. And that way, when you were ready to call it, if you wanted to display a number, you could do so. If you wanted to display a string, you could do so. Same method name, just taking different data. Now what you cannot do is have something that accepts the same data type but returns a different value. What do I mean by that? You see this one that returns 2 doubles being multiplied by each other? You cannot make another one that did this. Int multiply double D1, double D2, and then return D1 times D2. Even if you converted this to an int, right? Like that, the code is simply not going to compile. And the reason why is it wouldn't know which version of multiply to call. So if in your code where you did double D is equal to mult 3 comma 4 and it was trying to hook that up to whichever method needed it, it would come up, well, I mean, it doesn't know which one, because we have two different versions that have the same parameter list. And if you have two methods that have the same parameter list but different return types, that's a syntax error. The only way you can do it is if the variables have different data types or different numbers of parameters. I said variables. Methods. If the methods have different data types, like when we did the display int and then the display string, or different numbers, or both. Yeah, that's overloading. Let's go back and look at their definition again. Overloaded methods are ones that have the same name and different parameters. I should say different parameter types, but that's okay. Alrighty, we're done with that chapter. Now I do want to bring that up. So you've already written a car class if you did this assignment. We're going to make a new assignment that modifies the car class. So what we're going to do is, I guess we'll take note of that. We've already done an assignment where we created a car class. Now we are going to update it with methods based on Chapter 7. Along with the methods shown in the UML, we need a toString method, a equals method, and a constructor. So the UML is going to look a little bit different now. Let's modify the UML to show what it's really going to look like. Along with all that stuff, it's going to have a toString, which doesn't return anything. Which returns a string. We're going to have equals, which takes an object, which returns true or false. And we're going to have two constructors, one a custom constructor and one a default constructor. That's a default constructor, it doesn't take any parameters. And then another one that takes in miles, which is an int, gallons, which is a double, and MPG, which is a double. And I know we've done something like that, where we created a constructor that passed data in. Okay, so we're going to modify our program a little bit. Have your program create two cars, and then have your program create two more cars using the custom constructor, the parameterized constructor, like this. Car C3 is equal to new car, and we're going to pass in these values, miles and gallons and miles per gallon. So it's got 20,000 miles. It has a tank that holds 20 gallons, and it gets 35 miles per gallon. like this. Maybe we'll have it create 3 more cars. Print the cars out using toString, and then test to see if C3 equals C4, which it should, and if C3 equals C5, which it shouldn't. So these are the additional things. All right, makes sense, y'all? Everybody remembers how to create a constructor that accepts data? We're iffy on that. We're all good. Thumbs down means we talk more about it. Nope. All right. So this will be 11.
The only question I had was, you know how we started having 2 classes per package or whatever? Is the point of that to make the one packet look cleaner? Is that why you have 2? Because you could do this.
Yeah, the question is, why did we break it up into 2 classes?
Yeah.
We can throw all the classes in the main class, but to encourage reusability, you want to break them into their own files, because then you could pull your car class or your sphere class or whatever into another project really easily.
So then, like, also in like the real world, you'd also break it up?
Absolutely, absolutely. The real world rules are typically 1 class per file. And yeah, you can do it. You can get more than 1 in there, but it's not preferred.
Okay. That's
Yeah.
what I was wondering why we were doing.
Yeah, yeah.
That makes sense.
Get that uploaded. Into homework 11. Upload it. That's my big trick, is to create the Dropbox and not give you all the instructions. I think we'll do that this time. Let's take a look at what we're going to do next. This needs to be arrays, and if it's not arrays, we're going to skip ahead to the chapter that is. Yeah, we're going to skip that. All right. Now we're going to talk about arrays. If you've taken Python courses, you've seen something similar to arrays called lists. However, there are key differences between what a list is and what an array is. And these changes also hold true when you take C++ and talk about arrays. They are very different in some ways than Python lists. But in some way, there's some parts are the same. You'll see what I mean really quickly. The way you define an array looks like this. An array is a list of, no, I can't use that word. It's a sequence of values. It's not just one value. You know, previously we would do something like this. My name is Fred, right? Well, what if you had several names? You could do this. Name 1 is equal to, Fred. Name 2 is equal to, Bob, and so on. But that's stupid. You don't really want to do that. If you have a series of values, you want to store them in one variable so that you can process them all sequentially. How would you write your program so that it could do something on name 1, name 2, and name 3, and you may not know how many names you have coming? So instead you declare it as an array and you store the values in it that way. So you say, okay, I have an array of strings. That's what the square brackets mean. I have an array of strings. And I want 3 of them in there. I'm going to call it names rather than name to imply that there's more than one. Then you start putting values in it. Names element 0, the first one, is equal to Fred. Names element 1 is equal to Bob. Names element 2 is equal to Susan. Like that. Now in Python you can keep adding to it. You could add as many items to your list as you wanted to. You can't do that with arrays. Once you have declared your array, it's fixed in size. If I wanted to go and add Betty to this list, I'm in trouble. I've already filled it up. There's already 3 items in it. So notice that although this says 3, we went from 0, 1, and 2. And that's based on zero-based indexing. You can do arrays also like this with what's known as an initializer. So string colors is equal to, and this looks a lot like Python, red, green, blue. Except in Python we use the square braces. Now we have an array. The compiler goes ahead and declares it to be 3 long, and then behind the scenes it kind of does the same thing as it did here, so that element 0 is red, element 1 is green, and element 2 is blue. So an array is a sequence of values. They have to all be of the same type. Another difference with Python. This isn't entirely an array of strings. I then can't turn around and go, okay, well I really wanted that one to be a float, Can't do that. They all have to be of the same type. After a while, there are programming techniques you can use to where you could store different types in the array, but they all have to be related to each other using inheritance. And that's way past this class, not next class when you take advanced Java. All right, I don't know why the very second thing they say in the PowerPoint is an array is a limited version of a class. Yeah, it is, but that's just because it has to have some. They've made arrays a class so that they can tack on a few methods. The ability to get the length of the array, for example. That's one difference between this and C++. In C++, once you declare an array, you don't know how long it is. You could create an array of 20 elements, but unless you do something special, there's no way of asking the array how long it is. And that's not true of Java. You can just call the .length method, and it will return you the length of it. So it's a group of related data, sequential data. It stores the methods that operate on that data, which are very few actually, because you access them directly, as I was showing you here. So we have a phone list, which is a series of, I guess, you could either make them strings, because otherwise I don't know how you would put 0, 0 in front of it. If you were going to try to store them as numbers, they'd better be longs because they're greater than 2 billion. So if you're going to access your phone list variable, here's how you do it. That's the first element, 0. That's the second element, 1. That's the third element, 2. You just have to get used to the idea that in computers you start counting at 0. It's called zero-based indexing. So if you have 5 elements, you can access elements 0 through 4. Or you could say that you can access elements 0 through n minus 1, where n is the length of the array, if you want to get all mathy about it. If you want to change an element, you change it like that. You use the index value. If you want to print one of them, you print it out by using the index value. That's the second element of the array, because you start counting at 0. We've changed the first one, and then we're printing out the second one. So here they create an array called phone list. And they did make it an array of longs, even though, like I said, I don't know how you would put some zeros in at the beginning of that. That looks spurious. That should be removed. Anyways, let's do this. Let's create some code that uses arrays. Import which one?
The util scanner.
Yeah, go ahead and add the import scanner. Scanners are more fun. They let us type things in. That also gets annoying when we're debugging it, right? You know, have to type stuff in every time. But anyways. So, get rid of my package statement. Import java.util.scanner, uppercase S. Down here in main, I want to ask the user how many names to put in our array. So system.out.println, how many names to enter, question mark. And then int number of names, which is going to serve as our array length, is equal to the scanner.nextInt. Now we're going to declare our array. String, because it's an array of names, square brackets, you don't have to put the space there. Let's give it a word, a variable name, names, is equal to new string, and how many do I want? I'm not going to hard code it to 10 or 5 or 3. Instead, we have asked them to enter the number, and so I'm going to put it right here. I forgot to create the scanner. I'm going to have to go back and do scanner sc is equal to new scanner. So as soon as I finish typing this line, I'll do that. So string, square brackets, names is equal to new string, square brackets, num names, in square brackets, semicolon. But we do need our scanner. So above everything, scanner sc is equal to new scanner system.in. All right, now let's loop asking for names to insert into the array. Because we could just do this, don't type this. The first person's name is Fred, whatever, but we want to ask them for this stuff. And here's what we don't want to do. We don't want to say sc.next and just do that, over and over and over, because we don't know how many names they have asked for. So we can't just code it like that. It has to be in a loop. And our loop control variable is going to be the index into the array. So let's declare our loop control variable, set it equal to 0, and we're going to go while. I could have used a for loop for this. Why not? Delete all that. For loops are the best loops. Int I is equal to 0 while I is less than, what's the variable that contains our number of names? Well, what do you know? It's num names. All right. Num underscore names, semicolon I plus plus. Let's tell them that we want a name. System.out.println. Enter a name. Let's let them type it. String s is equal to sc.nextLine. I'm going to use next line so that they can type in both the first and the last name. And let's store it into the array. What's our array called? It's called names. What's our index? Our loop control variable, it's I, equals the string that they just entered. Now let's print the array out. Same kind of loop. Except now I'm not necessarily going to use num names. Instead, I'm just going to ask the array how long it is. So there's my index counter again. It's I is equal to 0. I is less than names dot length I plus plus. Let's print out that name. System.out.printf %2d. We're going to reserve 2 spaces for the number, and then followed by %s. So quote %2d space %s \n, and we're going to fill in this d with the integer I, and we're going to fill in the string with that element of the array, names subscript I. When I say subscript, I mean square brace. Sorry, some textbooks call it a subscript. Name index I, name square braces. I will use those terms interchangeably. Let's test it out. Hammer and broom. Run it. Could not load main class. I've done something terrible and I wonder what. Oh, when I deleted the Word package, I didn't move it to its correct place. So go up to the top of the code, move class to correct folder. All right, now to run. All right, how many names to enter? 3. Enter a name, enter a name. Why did I do that? Bob. Enter a name. Joe. Okay. The problem is that I used .next in one place and then I used next line. And whenever you mix those, you get into trouble. So I'm going to fix it so that I'm not doing that. I'm going to use next line everywhere, but there's one place that I have to fix. And what is that? Where's the one place that we did not use next line? Right, so let's read that into a string instead. I'm just going to comment this out and then say string s is equal to sc.next line, but then we have to convert what they type in. So int num underscore names is equal to, we have to parse int, integer.parse int with a capital I. Integer's got a cap too. Capital I integer dot parse capital INT parentheses S for that string. Now we'll be good to go. Or we'll get an error. S is already defined. Well, all right, if you say so. Oh, yeah, what do you know? Right there. Okay. I had to take out the redeclaration. I guess I'll call it a different variable. String S input. String S, yeah, I could have called it name. Logically, I like doing this, what you suggested. String name is equal to that, and then name subscript I is equal to name. But the problem is when I start doing that, then people start throwing in S's on the wrong variable and they start taking them off on the wrong one. So I steer away from making variable names that are too close to the array name, even though that's the most logical thing. I guess I'll leave it though. Y'all are smart enough to know that this is not the same as that this is a singular variable holding in one string, and that this is an array holding a lot of strings. Yes, sir.
Could you show me the very bottom, the last?
The for loop. There we go.
Yeah.
Do we not declare I inside the for loop?
We did in both places.
When I do that, I'm getting an error. When I delete it, the error disappears.
Your Mac is crazy.
Maybe that's what it is.
I'm kidding, but did you do that on both of them, or just the first? Okay, see, we have int I is equal to 0. I deleted that, and you didn't catch me delete it, so take that one first out.
This one?
Yeah, take that line out.
Okay.
Yeah. And we could have fixed that by taking the int out, just like you were doing. So we got it going. You can run it, ask for names, and we print them out. Cool deal. I'll be right back. Sometimes I've had people lose confidence in themselves when they hit arrays, or they took a programming class in the past or in high school or something like that. And I didn't get arrays. I didn't understand that. Or, yeah, that was beyond me. Hopefully they're not. Hopefully they're not. So, an array is a way of addressing a sequence of values. So like if you say, you know, I'm going to send a letter to the White House, you know, that'll probably work. Why? There's only one White House if it's all capitalized, you know, White House, Washington, D.C., or whatever. But, you know, the rest of us live in apartments or, you know, on streets where there's all sorts of different things on the street. So you send a letter to, you know, 123 Main Street. You send a letter to 124 Main Street. You know, and then you send a letter to 125 Main Street. Right? Main Street is the entity, and then this is the index into the entity. Or apartments. Apartments all have, you know, numbers. Maybe you also have an apartment complex with letters, but, you know, just bear with me. So you have a apartment called, I don't know, Oakwoods. Oakwoods 0. Somebody's living there, you know. Oakwoods apartment 0 equals something. You know, Oakwoods apartment 1. Yeah, right, like there are any apartments that start with 0. Sorry, that's kind of stretching our disbelief. Oakwoods apartment 2. And so on. Or rooms in a motel, right? Motel 6, you know, room 128, room 100, room 101 is equal to. So that's just the same as an array, you know. A variable can be a single thing like that. There's only one White House. Or it can be a whole bunch of things that exist with the same name. We have a whole bunch of different street addresses that share the same zip codes, for example, 73130. You might have a main street in that zip code, but you might also have a main street 74145, you know, elsewhere. How are you going to distinguish which one is which? Because you have different zip codes. It's a way of indexing, you know, the United States, breaking it up into different components so that you don't have name collisions to where you don't know whether Main Street is applying to the one in Stillwater or to the one in Midwest City. So I hope that's clear. Let's go back to our code. We're going to make a couple of more changes to it. Some are just sample declarations. Declare an array called nums and just put 3 or 4 numbers in it with an initializer list. Int nums equals, just type in some numbers, 3, 1, 4, 1, 5, 9, something like that. String, an array of Trek characters, Star Trek, is equal to Kirk, end quote, McCoy, end quote, Scotty, like that. And I did something wrong. Oops, I did the Python syntax at the very end. That is supposed to be a close curly brace and a semicolon. So if we wanted to fire Kirk and put Picard into that list instead, how rude, we're going to have to put a number there in place of that X. What number are we going to put there? Remember zero-based indexing. Yeah, so it'll be 0. So now if we print our list out, it's going to print out 0. Excuse me. Now if we print our list out, we're going to see Picard, McCoy, Scotty. If we want to change this 9 to an 8, we've rediscovered the digits of pi, and we think that this one's an 8. What's that number's index value? Yeah, I have to count it, but that's 0, 1, 2, 3, 4, and that's correct. It's 5. So if we wanted to change that to an 8, nums 5 is equal to an 8. What if we goof? What if we try to access name number 3? There is no name number 3. That's name number 0. That's name number 1. That's name number 2. We're going to add somebody to our cast of Trek characters. Trek 3 is equal to Sulu. Let's run it. And you should get an exception. This should not run successfully. You shouldn't get a compilation error, which I am. I have too many closed braces somehow. Alrighty. I see some little warnings out here that I'll click on in a minute, but first I just want to get my point about out-of-bounds indexing done. How many names to enter? 1. Enter name, Bob. Alright, here we go. Array index out of bounds on line 36. Well, lo and behold, it's this. We can't access element 3 because we can only go 0, 1, or 2. We can't append a new item into this array. It's fixed in length. So arrays are fixed in length. To change their length, you have to redeclare them. And then you lose all the data that was in them. Reallocate them with another new. So if I needed a Trek cast that supported 10 characters, I could do that. I could say Trek is equal to new string with 10 people in it, like that. But then I've blown away this array. This old array is now orphaned data. Nothing's pointing to it. Hopefully the garbage collector will come and scoop it up. So what you got to do, I'm not going to even talk about what you got to do to do that. There are other data structures called array lists, which work like lists in Python, where you can append to them. They are not fixed in length. They are variable lengths. They are so-called dynamic data structures because you can delete from the middle of them, you can append to the end, you can insert into the beginning, all that kind of stuff. Whereas pretty much you can't delete without writing code. What if we wanted to delete Kirk from this list? Well, I guess it's Picard now. What if we wanted to get rid of that 3 and shift everything over? Well, what you'd have to do is you'd have to copy that value into that one. You'd have to copy that value into that one. Have to copy that one into that one. It's a very repetitive thing, so you'd write it in the form of a loop. That one into that one into that one, and you'd put a 0 on the end. That's really annoying, isn't it, if you had some other data structure where you could just say delete element 0 and it would handle it for you. So really, once we get there, that's what we're going to do. That's what you're going to want to do. So an array is a variable. You must declare it. Here's an array of ints. It's not allocated, but it is declared. Can't use it yet. Here's an array called double, and not called double. It's called work hours. It's an array of doubles. And here's an array name called names, and it's allocated as an array of strings. Then when you're ready to declare it, you use the new keyword, just like we did with our scanner and with our other objects, except instead of parentheses to invoke a constructor, arrays don't have constructors. You instead pass the length in, inside of square braces. So we declared our phone list, which consisted of a whole bunch of longs. Well, we don't know how many longs it is when we declare it. It could have 0. You can have an array of length 0. It's kind of a weird idea. You have a list with nothing on it. Santa's going to come deliver presents, but he doesn't like anybody, so his list is 0 names long. So, and then phone list is equal to new long. That creates space for 10 longs to be stored. That's the array creation, also known as the allocation Allocation and creation are the same thing. So provide a single statement. Okay, you could do both of them at the same time. Long array phone list is equal to new long array of size 10. Provide a single statement that declares, creates, and assigns a 100-element array to store book titles. So to store book titles, what data type do we need? Yeah, let's use strings. So string, and I guess we're going to call it titles, but I can't just do this. I've already made a mistake. What do I need to do to make it an array? Yeah, I got to put the square braces. There we go. Titles is, and now I actually have to use the new keyword, and I want 100 of them, like that. Or you can use an initializer, which lets you get away from having this new keyword and specifying a size. If you use an initializer, the compiler figures out the size. So if you have 3 students, those are their names, string array students is equal to, and in curly brace you list your students. When it's done, students is an array of 3, length 3, equals the number of elements in the initializer list. So when you do that, you do create the array, but you don't have to have the new operator in it. Yeah. Guess they could have, well, but no, they didn't do that. Didn't make it work like that. So arrays do get default values, unlike local variables. If we went in here and we did, x, what? X equals 3 plus 2. That's not going to compile. What if we did this, int x, and then we said system.out.println x? Is that going to work? Why is that not going to work? Variable x has not been initialized. But with arrays, you can. They do get initialized as they are created. In this language, not in C++ or C. So if you do this, int xa for an array, or ai for an array of ints, is equal to new int, we could have an array of 3 ints, and then we try to print out ai element 0, that's actually going to work. It would print out a 0. Every space in the array gets allocated to a 0. If they're booleans, they get allocated to false. If they're strings or other objects, they get allocated to null. Null is just another fancy word for 0, so that kind of makes sense. And if you think of true as being like the value 1, then false is a 0. So yeah, it gets filled full of zeros. The array does. So the default values for floats, 0.0. Default values for states is null. We haven't seen null too many times. Let's make an array called cars. Car companies. So it's going to be an array of strings. Let's just call it brands. Is equal to new string, and we want 3 different brands. Now let's print out the first brand. System.out.println brand subscript 0. Or brands subscript 0. Sometimes I waffle on whether I like having S's on the name of arrays or not. It would kind of make sense just to be able to say brand 0, just like you say I have name 0, name 1, name 2. But it's also kind of visually nice if you see a plural noun like that, it's an array. Now if we run it, it's not going to have anything nice there to look at. By the way, when it says how many names to enter, just type 0 and it won't do, oops. I still have that problem. I never fix that error on line 36, where I tried to change one of them to Sulu, so I'm just going to comment that out. If you're getting that array index out of bounds, make sure that if you typed it in, that trek square bracket 3 is now gone. Notice that that's not a syntax error. The code does compile. It's a runtime error. Gets into a state from which it cannot recover. It has no idea where it was supposed to store that data, but it sure can't store it in that array. Okay, name standard 0, and it printed out null. That's because it is an unallocated spot. We have room for 3 strings, but all 3 of those places are just empty things right now. Let's put some data into our strings. So string, I don't know, S1 is equal to Ford. String S2 is equal to Chevy. String S3 is equal to Toyota. And now let's put those into the array. Brands subscript 0 is equal to string 1. Brands subscript 1 is equal to S2. Brands subscript 2 is equal to S3. Now if we print out brand 0, it's actually going to have some data. It's going to equal Ford. I'm just going to copy that print, move it down here. How many names to enter? 0. So it printed out null the first time because it was unassigned, an unassigned string. It didn't reference anything. Anytime you create a reference variable, it's initially set to null. If I did, well, like if I did this, scanner SC, but I didn't put anything in it. It's uninitialized, but if you declared it somewhere else where it actually could pick up an initialization value, if you made it an instance member or whatever, it's set to null. It doesn't point to any scanner whatsoever. It's not until it sees equals new scanner that it stops being null and gives it something else. And the same is true of an array of reference types. And a string is a reference type. It is a class. Oops.
How do you print out the entire array?
Pardon me?
Like I know in Python, if you say print and then you put a list statement, it'll print the entire list.
Ah, good question. How do we turn the string, the array, into a single string for quick printing? Well, the arrays class with an S has some helper methods. Let's see if one of those would help us. I'm going to Google it probably really quickly. Arrays dot binary search as list, copy of, as list would do it. To string. Yeah, that sounds good. Let's do arrays dot, I'm not sure if this is going to work. To string parentheses, and we're going to pass in our brands array. I'm going to put that on a line by itself. Let's see if that works. Yep, that worked. Okay. A little bit more trouble than it is in Python, but we got it to work. What we wish we could do, like we could in Python, is do this. System.out.println brands. That'd be nice. It doesn't work. If you run it, all you do is you get the variable name and a hex value, hexadecimal value. Like that. Not the name of the variable, the type. It says java.lang.string, and that's the hash value, the hexadecimal for it. So if you want to print out the array in a quick and dirty fashion, you can do that. Or we use an array. Let's print out, not an array, we use a loop. 2 different kinds of loops though, including one that we haven't seen in this language yet. We've done this one. For int I is equal to 0, I is less than the number of brands, so I less than brands dot length, I plus plus, and then system system.out.println that brand. So brands subscript I. That's one way. This is shorter syntax. I think this book calls it for each. That's a term borrowed from C#, which actually uses the keywords for each. Other books call it something else. For string s colon brands, and we did do this a lot in Python, system.out.println s. And I'd already declared s somewhere else. So let's pick another. For every string text in brands, print out that text. You can see that that syntax is considerably shorter, right? That's a for each loop. You read it like this. For each string text in the brands array, print that text out. And the same syntax works regardless of whether it's a, numbers or strings or floats or whatever. We had another array up here that was a series of numbers. Let's print them out using a for each. For each int I found in the nums array, system.out.println I. Except I don't like using I as my iterator there. I use I as the index value. So I'm going to change that. I could change it to E for element or V for value. For every int value that's in the nums array, print out that value. Like that. I could have reused that variable name here as well. For every string value in brands, print out the value. There is a key difference between a for loop and a for each loop, though. When you're using for each, you're not allowed to change the array. And when I say you're not allowed, you just can't. If I did this, if I said text is equal to empty quote, it's not going to actually modify the brands array in any way. If I went down here and I did value is equal to 77, it's not going to touch the original array. Why? Because value is just a copy of whatever was in the array at that point. So value is getting copies of these elements, and then if we, change that value, it doesn't matter. The original is still out there. But if you use a iterator variable like this, you actually can change the array as you go through. If we did this, brands subscript I is equal to who's our favorite car company? BMW. Then every car brand, when we were done, would be BMW. Every element would have been reset because we have direct access to the array. That's how we're printing them out, and that's how we can change them. So if you need to change the value of the array, you don't use a for each loop. You use an iterative for loop like that. Most of the time you aren't changing the value of the array as you step through it, though, right? Well, I won't say that, not most of the time, but quite often when you're going through the array, you just want to display the values or you want to sum them up. Let's write a sum function. Int total is equal to 0, and then for every int value in the nums array, total equals total plus value. Or if we were going to do it with the index-based for loop. For parentheses int I equals 0, I is less than nums.length, semicolon I plus plus, total, I'm going to use the short form, plus equals value. But it's not value anymore. I don't have that variable. I need to get it out by its index number. So total plus equals nums parentheses I. And I needed to reinitialize total equal to 0 up here. So I'm going to go above my for loop and say total is equal to 0. two different things to accomplish the same thing. Both of these loops give identical results. Which one do you like better? Especially if we made this just say total plus equals value on that first one. They look very similar, but I prefer for each loops. I like that top one. Less to type in my mind. But you got to know both of them. At first, Java didn't have this syntax, this right here, the for each loop, when it was first created in the 90s. Alrighty, I think we're almost done. How to print an array using its index counter. We've seen that. To get the array length, you give the array name dot length. Here they note that if you're getting the length of a string, you use dot length with parentheses after it. If you're getting the a length of an array, you do not. So if we did this, and this would be the last thing I type, string street is equal to main street, and I wanted the length of it, int x would be street dot length, parentheses in parentheses. But if I have that brands, x is equal to brands dot length without the parentheses. Length is a method of the street class, but it's a property of the array class. So they came up with a new mnemonic. Are you going to remember this? I never do. ANSI, arrays, no, strings, yes. That's with respect to the parentheses. Whatever. Usually what you do is you type it in, and then if you get it wrong, NetBeans gives you a compile error and you take it off. But all right, let's stop there. Which part?
Just that, the last part.
Okay, so, oops, sorry.
And I did something wrong earlier. Whenever I press build, I'll press in the number of names to enter.
Yeah.
It'll automatically print 0 and then the next number. Or it'll print enter the names twice if I enter it two times.
Let me come look.
Okay.